Hello and welcome to another episode of Hockey Central. I'm Taylor Embry with The Athlete.
Jillian Forney with the plays. Jessica Hurley with the works.
Haley Cook with the hits.
Did you guys see those Icemen over the weekend?
Yeah.
Oh my gosh, they were flying. Oh yeah. Seems like they could have went on forever if it weren't for friction and gravity. Newton's first law does state that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an unbalanced force. Here, we see the hockey puck staying at rest until a player comes by. The coefficient of sliding friction is found by taking the force of friction over the normal force, which is the force perpendicular to the object surfaces. The two object surfaces here would be the blade and the ice. Inertia is also connected in Newton's first law, which is the natural tendency for an object to stay at rest, or an object to stay in motion. Oh, look at that hit!
Ow. Well guys, as you can see, collisions, just as Newton's third law states, comes in pairs. Newton's third law states that forces come in pairs. The force of object A on object B is equal in strength in opposite direction than the force of object B on object A.
Man, this game's getting rough.
Yeah, they're pretty violent, I'm not gonna lie. So you guys, collisions also have to do with the law of conservation of momentum. This means that the total momentum before a collision is equal to the total momentum after the collision, if there are no external forces acting on the system. It also ties in with conservation of energy. No energy can be created or destroyed. It can be transformed from one form to another. The amount of energy remains, but stays constant.
To find the force of either the puck or the player, you need to take their mass and then times it by the acceleration of how fast they were going. And that would be measured in newtons. And by finding the force, you can also find the work, which is the product of displacement and the force in the direction that it was moving. As Haley mentioned, the momentum, which is mass times velocity, or a speed with a direction, is not to be confused with force, which is mass times acceleration.
Here the skater is demonstrating constant speed. His speed is constant because the speed does not change during the length of the time. As the player spots the puck, he speeds up to keep up with the others. He is accelerating positively. His velocity increases, causing the acceleration. When there is an acceleration, there is usually an unbalanced force. Newton's second law states that the acceleration of an object is directly proportional to the unbalanced force acting on it, and inversely proportional to the object's mass. The direction of the acceleration is the same as the direction of the unbalanced force. If you watch closely, you can see the player push off the ice, creating an unbalanced force, causing the skater to move forward. The force he uses to propel himself, the faster and more distance he will travel. If a player has a smaller mass, it will not take as much force to travel the same distance.
As Taylor said, gravity comes to play in here. Gravity is the attraction between two bodies due to their masses. The puck, the skater. It has a pull on everything. One could skate on forever with just one push.
Who would have thought there would be so many physics aspects in one game of hockey? I mean, it's just crazy.
That is crazy.
Well guys, that's all for tonight. Join us next time on Hockey Central.
Bye.
Bye.